Hello, everyone. I am sorry that I have to be gone today, but the soccer team is up in Kalispell, and I am with them. So we're going to continue forward, though, and we're going to be working on section P.6 in your notes. To start, though, I'll put up the answers to section P.5, which was on factoring polynomials. If you would get your homework out so you can check your answers. So if you need to pause the video now so that everyone can have their homework out, feel free to do so. Otherwise, I'm going to assume that we're good to go and read off the answers. So in P.5, question 3 was 3x times a quantity x plus 2. 7 was x plus 3 times x plus 5. 17, x plus 2 times x plus 3. 19, x minus 5 times x plus 3. 21, x minus 5 times x minus 3. 23, 3x plus 2 times x minus 1. 31, 3x minus 2 times 3x minus 1. 25, 3x minus 28 times x plus 1. 39, x plus 10 times x minus 10. 93, x to the 1/2 times the quantity x minus 1. So there are your answers to P.5. Where that homework is, if you would, please try the following warm-up questions. So pause the video now, take maybe a minute to try these questions and see what you notice when you substitute in the three values. So pause the video now, come back after a minute. Okay, this is what you should have noticed. When you substitute in 1 to the first one, you end up getting 12 over 1 minus 3 is negative 2, you get negative 6. If you substitute in 2, you get 12 over 2 minus 3 is negative 1, you get negative 12. If you substitute in 3, you get 12 over 3 minus 3 is. If you grabbed your calculator and typed in 12 divided by 0, it would give you an error. The reason why is because this is undefined. You cannot divide by 0. So what we see here is if you have a fractional statement, the bottom, the denominator can never be 0, because if you divide by 0, it's an undefined value. We'd say in math that the value doesn't exist. So that's what we're going to be looking at when we study in P.6 items that are called rational expressions. So have your note packet out to section P.6, day 1. We're looking at rational expressions. A rational expression is chosen because of the word ratio. It's a ratio of two expressions, two polynomials. So here are some examples where you have one polynomial dividing another polynomial. All of these are rational expressions. It's the quotient of two polynomials. The set of real numbers for which an algebraic expression is defined is the domain of the expression. So the values that I can substitute in and it will return a value. Because rational expressions indicate division and division by 0 is undefined, as we just saw, we need to exclude any numbers from a rational expression's domain that would make the denominator be 0. So we're going to look at all the values that would make the bottom be 0 because we need to exclude them if I were to make a table to eventually plot these. So eventually the goal would be to graph items like these. If I were to graph them to start, I'd probably make a table. But I need to know what values I cannot pick because it would make the bottom part be equal to 0. So example, find all the numbers that must be excluded from the domain. What values can I not pick? And I cannot pick any values that make the bottom part be 0. So I'm going to look and see which values are going to make the bottom part be 0. So for the first one, I want to know when is x squared minus 9 going to equal 0? Well, if I solve by adding 9 over, I'd get x squared equals 9. And then I can take a square root. Take a square root of both sides. And I would get x equals, well, when I take a square root, I get plus or minus 3. Those are the values I need to exclude from picking. You could have also got it from factoring. If you had factored the bottom, I need two numbers that multiply to be negative 9 and add up to be 0, because this is really x squared plus 0x minus 9. That's why we practiced factoring in the prior section. I would get x plus 3 and x minus 3. And if I see what values would make the bottom part be 0, well, negative 3 would make the first one be 0, and positive 3 for x would make the second part be 0. So factoring is going to be really helpful. It's actually what I'm going to do for this second one. So if I want to know when is this bottom part going to be equal to 0, let's factor it. So I end up getting 5 over, I need two numbers that multiply to be 12 and add up to be 8. Those numbers are going to be 2 and 6. So when I factor it, I get this. I want to know when is this bottom part going to be equal to 0. Well, it will be equal to 0 when this x is equal to negative 2, and it will be 0 when this x equals negative 6. So I need to exclude negative 2 and negative 6 from the table of values that I would eventually make to graph this. So we call those excluded values because they would make the bottom part be 0 and the graph would be undefined there. It wouldn't return a y value. That's what we mean when we say exclude. So that's the first part, knowing what values I could not pick if I were making a table. The second item we're going to look at is simplifying rational expressions. In middle school, the version you did of this was simplifying fractions. Fractions are rational expressions. They're rational expressions when you compare one number to another number. In high school, we do the exact same thing, but we're comparing one polynomial to another polynomial, whereas in middle school you did with numbers. So we'll look at what's the similarity and differences between what you did in middle school and then today. So are the following fractions simplified? Why or why not? Well, the first one is not, because I could divide both in top and bottom by 3. If I divide by 3, I'm going to end up getting 5 over 4. Then I would say 5/4 is simplified because 5 and 4 have no common factors. 10 over 7, is that simplified? Yes, because there is no number that goes both into 7 and 10 that I could divide out. So just like we can simplify fractions in middle school, we can simplify rational expressions here in high school. A rational expression is said to be simplified if its numerator and denominator have no common factors other than 1 or -1. That was the exact same rule you used in middle school for fractions. The following procedure could be used to simplify rational expressions. Factor both the numerator and the denominator, and then divide out any items that they have in common. So same thing you did in middle school is going to be the same thing that you do here in high school, just instead of using numbers, we're using rational expressions. So goal is to simplify. Well, let's first factor. So if I factor this one on the left, well, this is a 1 out front. 1 and 3 have no common factors, so I can't divide anything out here, but x cubed and x squared have a common factor. I could divide out an x squared. So if I divide out an x squared from the top, there'll be an x left here because there were 3 of them. I've divided 2 out, plus the 3. It didn't get divided out. This had x squared. I divided both the x is out, so that's all that's left behind. So the top looks like that. The bottom is x plus 3. I'm just going to put parentheses around it because they're really grouped together. And then I notice x plus 3 and x plus 3 can divide out. So I'm left with just x squared. Second one. Factor the top. I have x squared minus 1. We call those a difference of squares because it's a subtraction, and each of these are a square term. So you might recognize that this is going to make x plus 1 and x minus 1. If you did not notice that, then maybe you can write this as x squared plus 0x minus 1. All divided by x squared plus 2x plus 1. Then I need two numbers that multiply to be -1, add up to be 0. Well, that's the difference of squares we talked about. That's going to be x plus 1, x minus 1, because -1 and +1 will add up to be 0 and multiply to make -1. Down below, two numbers that multiply to be 1 and add up to be 2 are 1 and 1. So I get x plus 1, x plus 1. Now it's factored. That's step 1 of the suggestion. Factor the top and bottom, the numerator and denominator. Step 2 is divide out any common factors, and that's going to be this guy. So what is left? X minus 1 over x plus 1. I'm just writing the grouping symbols around this because a common mistake people make is they'll start to say things like, oh, these x's will cancel out. No, they do not. Those are grouped together. This is x minus 1, this is x plus 1. Those are different terms. So I cannot just divide that out. This x is grouped with a -1, this x is grouped with a +1. Those are not the same statement. So you cannot divide out the x there. You're left with x minus 1 over x plus 1. I'm going to give you a chance to try. So pause the video now for let's say a minute and a half. First, state the excluded values, and then go and simplify it. Factor the top and bottom, divide out any common factors. So pause the video now for a minute and a half. Give the question a try. Okay, let's do this. So first thing I would do is factor. If I factor the top, two numbers that multiply to be 16 add up to be -8. Are going to be -4 and -4, so x minus 4, x minus 4. If I divide out down here, they don't have an x in common, but they both have a 3, so if I divide out a 3, then there'll be an x minus 4 left behind. So I factored it. Now I can state the excluded value. The excluded values, so excluded values, or any values that would make the bottom be 0 that I could not pick if I were making a table. Well, this 3 is always going to be 3, but this right here could be 0. This would be 0 if x equaled 4. So that's the excluded value. That's the value I could not pick if I were making a table. Now they ask me to simplify the statement. So I simplify by dividing out any common factors. This x minus 4 could cancel any one of these. It can't cancel both because it's just one of them. So cancel one of them out. When I simplify this, what's left up top is an x minus 4. What's left down below is a 3. So once I simplify it, I'm left with that statement. So there you go. There's the first part, is simplifying rational expressions, the high school version of fractions. Second part we're going to be doing is multiplying and dividing them, just like you multiply and divide fractions. So this first part is not in the notes. You would just do it out loud. So how do you multiply fractions? Well, you eventually multiply fractions by multiplying straight across. Numerators times numerators and denominators times denominators. However, you might want to look if you can simplify before you multiply, because then the numbers won't be so big. So if I look, 9 and 15 could be simplified. They both are divisible by 3, so this becomes 3 and 5. The 8 and the 14 are both divisible by 2, so I divide by 2 and I get 7 and 4. Now there's no more common factors. When I multiply straight across, 3 times 4 is 12, 7 times 5 is 35. That's how you multiplied fractions in middle school. Now divide. How did we divide? Well, in order to divide, you actually multiply by the reciprocal. So I'm going to take 8/3, and instead of dividing by 5/9, I'm going to multiply by the reciprocal, 9/5. Same game now plays. If I'm multiplying, I multiply straight across. I might want to look if I can simplify first. This 3 and this 9 will make 1 and 3, and then I multiply. 8 times 3 is 24. 1 times 5 is 5. And if you can multiply and divide fractions, then you can do what we're doing today. Because now we're just going to do it not with numbers, but with expressions. Step 1, factor all numerators and denominators completely. Factor things out. Step 2, divide numerators and denominators by any common factors, like we did. That was the simplifying step here that I was doing in blue. That's divide out any common factors to make the items not as big. Step 3, multiply the remaining factors in the numerators and multiply the denominators. So multiply numerator by numerator, denominator times denominator. And there's the steps. So here we go. One example. First one, factor everything. Well, this isn't x plus 3. Can't factor that anymore. It's already factored. Times. Down below here, x squared minus 4. This is x squared plus 0x minus 4. It's a difference of squares. So it's always got to be the plus and minus of the square root of this number. So x plus 2, x minus 2. Factor the right rational expression. I need two numbers that multiply to be -6 and add up to be -1. That's going to be -3 and plus 2. Same goes on down here. Two numbers that multiply to be 9, add up to be 6. That's going to be 3 and 3. So step 1 is done. Factor all numerators and denominators completely. Step 2 is divide out any common factors. Well, x plus 3 and x plus 3 are on opposite sides of the rational expression, and they're a common factor, so they can cancel out. I see an x plus 2 and an x plus 2 are going to cancel out, and that's it. This is an x minus 3. That's an x plus 3. They can't cancel out. An x minus 2 is not going to cancel out there. So step 2, divide out. Now I just multiply. Well, this is really a 1 and a 1. So up top, the only thing that's left is an x minus 3. X minus 2 times x plus 3. Just put them together, and you're done. You don't need to go double distributing or foiling out the bottom there. You can just leave it as it is. So that's the answer. It's an example of multiplying. Now we're going to do an example of dividing. Well, in order to do a division question, we're going to change it to multiply question. We just need to make the reciprocal over here. So I'm going to rewrite this as a multiplication question. All over 12 times x over x plus 1. Now it's just the question we did a second ago. First thing I need to do is factor wherever I can. Two numbers that multiply to be 12 add up to be 13. Everything else is factored. This is x plus 1. So up here I'm going to get, what is that going to be? It's going to be a 12 and a 1. So x plus 1, x plus 12 over 12 times x over x plus 1. So when I factor this top left, I get the following. Now I divide out any common factors. I see an x plus 1 and an x plus 1. This 12 and that 12 cannot simplify. This 12 is all by itself. This 12 is with plus x. So it's grouped together. You can't cancel those out. Up top, I have an x plus 12 times an x left. Down below, I have a 12. And then that would be my final answer. If you wanted to, you could put this x out front. It doesn't matter. But Commutative property of multiplication says you could multiply in any order. 2 times 3 is the same as 3 times 2, so it would work out. That's it. Going to give you a chance to try. Just make sure you can do it. So pause the video now for maybe a minute and a half. Try this example. When you get your answer, check it with a neighbor. Once we're all good, you can unpause it and see how you did. So pause the video now, give it a shot. Okay, let's see how it went. First thing I would do is factor. So up top is going to be x plus 3, x plus 5. Down below on the left-hand side is a difference of squares, plus 4 and minus 4. If it's a division question, I'm going to make it a multiplication question by multiplying by the reciprocal. Now I need to cancel out any common factors. X plus 3 over x plus 3 is going to make 1. This is really 1 and 1. What else is there? There's x plus 4 and x plus 4 are going to make 1 and 1. The only thing left is x plus 5 and x minus 4 and a bunch of 1s. So up top, when you multiply 1 times x plus 5 times 1, I get x plus 5. Down below, 1 times x minus 4 times 1, x minus 4. These are grouped together. You can't just cancel these x's. They're part of a larger expression, and then you'd be done. That is it. Your homework is for section P.6, the first day. Answers are right here. If you'd like to leave the video paused and there, then you'd have the answers as you work. Otherwise, have any questions ready for me, and I will check both this assignment and the prior one when I am back the next day. Thank you very much, and have a good day.